Let's continue in section 3.2. We're talking about synthetic division. In the last video, we worked a problem where we took x squared plus 5x plus 9 and we divided it by x plus 3. And the answer was x plus 2 plus 3 over x plus 3. In general, what we're doing is we're taking a polynomial function like f of x, which could be to the second power or the third or the fourth or the fifth power or even higher than that. In the numerator, any degree polynomial, and in the denominator, the divisor is always first degree, is always x to the first with coefficient 1 in front, minus k. And so we have a division of the form f of x over x minus k. And then we write our answer. We write q of x, the quotient, plus r is the remainder, divided by the divisor x minus k. So now what we want to do is we want to express the same idea in a slightly different form. And so the way we're going to do that is we're going to we're going to multiply both sides by the least common denominator. And so that's x plus 3. And so when we do that, the x plus 3's cancel here on the left side, and we're just left with x squared plus 5x plus 9. And then on the right side, what we're going to do is we're going to keep the x plus 2 together. That's the quotient together. And we're going to multiply it by x plus 3. So I can write x plus 3 times x plus 2. And then I'm going to multiply x plus 3 times 3 over x plus 3. And of course, the x plus 3's cancel, and I'm just left with 3. So when I look at this now, I can look at the left side as a polynomial function, f of x, and the right side represents a new way to write that polynomial, an equivalent way to write that polynomial. So in general, what we would have is if we multiply both sides by x minus k, on the left side, x minus k's cancel, and we're left with f of x is equal to, and then on the right side, x minus k gets multiplied by q of x. And then the x minus k cancels with the x minus k in the denominator, and we're just left with a plus r. So again, the left side is any old polynomial, and the right side is a new way to write it. And this is an important idea. This has a name. It's called the division algorithm. Let's see an example. So first thing we should notice is that the directions are pretty explicit. They say take the function f of x and rewrite it in the form x minus k times q of x plus r. You see there's a little mistake in my directions. I think I can fix it right now and we'll be okay. Express f of x in the form f of x equals x minus k times q of x plus r for the given value of k. So here's our polynomial f of x, and here is the value k equals -3. So maybe the first thing we should do is think of this in the old familiar way. The old familiar way to give this problem is to say divide 2x to the fourth plus x cubed minus 15x squared plus 3x. Divide that by x minus k, x minus negative 3 is x plus 3. So this is how we would have seen the problem at the beginning of the section, and now we have a new way to think about the same idea. So the work is going to be the same. It's going to be the same synthetic division. Out in front of the house, we're going to put negative 3. And then underneath, we're going to put the coefficients of the polynomial f of x. So we're going to have 2, 1, negative 15, 3. And then notice there's no constant at the end. So we need to insert a term for the constant. We need to think of this as 0. We need to think of the constant 0 and include it. And if we wanted to, we could even go back to the original problem and we could say, hey, there's a plus 0 at the end, so that all of the powers of x are accounted for, from x to the 4th all the way down to the constant at the end. Okay, we've set up the synthetic division, and so now we can go through that. Do you remember how to do it? We're going to skip a space and then draw a line across, and then we'll bring the 2 down, and then multiply 2 times negative 3 is negative 6, and then add negative 5. Multiply negative 5 times negative 3 is 15, and then add, and we get 0. 0 times negative 3 is 0. Add, and we get 3. 3 times negative 3 is negative 9. 0 minus 9 gives us negative 9. Do you remember what that negative 9 is called? It's the remainder. And the numbers 2, negative 5, 0, and 3 represent the coefficients in the quotient. Okay, so now we just need to write our answer. So remember our answer up here, let's see here, let's look in the problem again. Our answer is supposed to be in this form. F of x is equal to x minus k. So x minus k is x minus negative 3, or x plus 3, multiplied by the quotient. The quotient is here at the bottom of our synthetic division. What power do we start with? F of x started with x to the 4th, so the quotient starts one smaller, starts with x to the 3rd. So we'll have 2x to the 3rd minus 5x squared plus 0x. I won't write that. Plus 0x simplifies, and then the constant at the end is 3. So I've written x minus k times the quotient, and then I just need to add the remainder on at the end. And so that's plus negative 9, or even better, if I just write minus 9. And there's our answer. We could verify that it's correct by multiplying it back out. If you multiply x plus 3 times 2x cubed minus 5x squared plus 3, and then you subtract 9 at the end, you'll get the f of x that we started with at the beginning of the problem. Okay, let's do one more of these to make sure we've got the hang of it. So here's the next one. Let's get right into it. Underneath the house, we have the coefficients of f of x, starting with negative 1, positive 1, 3, and negative 2. And out in front of the house, we just have the value of k, which is 2. Try doing the synthetic division. Stop the video, try to do the synthetic division, and then start again, and we'll go together. Okay, so we brought down the -1. We multiply and add. We multiply and add. We multiply and add. And there's an interesting thing. This time the remainder is 0. We'll see the remainder equal to 0 more as we do more problems. This is an interesting observation in the problem. Okay, we've got a quotient here, and we know that we can write f of x. We know that we can write f of x as x minus k, which is x minus 2, times the quotient, which is going to start with -1 times x to the second power, negative x to the second power, minus -1 times x to the first power is minus x, and then plus 1. And then plus the remainder is plus 0. We could write plus 0, but what we'd really like to do is go ahead and simplify that. And then we just have x minus 2 times negative x squared minus x plus 1. And we can box that up.